Hello, Honors Algebra! Mr. Lawrence here with your flipped lesson for Friday, February 3rd. It's not going to be a real heavy lesson because you guys are working on the faux quiz. I just want to point out a couple things that we might have mentioned in class to make your work a little easier, and then I'm going to explain a little bit more about the half-life and show you how you might want to approach the percentages. Okay, first of all, remember that when you have an equation like this, excuse me, sometimes it gets hard to work with the fractions, okay? Well, remember, if there is a negative exponent here, you can rewrite this equation into y equals 5 to the power x plus 2. It'll produce the same equation because the negative exponent means to use the reciprocal. So I flip the 1/5 and then I change the exponent to a positive, and you'll get the same graph. If you don't believe me, hold on one second. I pull up my handy dandy graphing calculator on my smartboard, and I'll type in the equation. What was it? 1/5 to the power of negative x. It might, I don't know if it'll like that. Let's see if that works. And plus 2, and then I'll zoom 6, and there's my graph. Okay, and you can see the asymptote showing up, okay, right here. And it actually, the graphing calculator makes it look like it's horizontal. It actually doesn't go horizontal like you know. All right, so let me see here if I can close my ink layer. Now, if I type in this equation that I say is identical, if it's not identical, I should get two separate graphs, right? In fact, let me do that. Let me make it so it's not identical, and that way you'll see that I'll get a different graph, and you'll understand what I'm talking about. And so let me graph that, and there you go. I get two different curves, right? Okay, but that's just to prove a point, so let me come down here and make it identical. Plus 2. And look at that, you only see one curve because both equations produce the same thing. All right, so remember, that can be a real helpful tool if those fractions are screwing you up. Now, if you have a fraction like 3/4 raised to the negative power of negative x, that may not help so much, but when it's a fraction with a numerator of 1, then certainly that's the way to go. Okay. So enough about that. Let me minimize my graphing calculator and get my work back up here. And I'm going to set up a half-life situation here. Okay, let's say we were talking about cesium-137. And now, understand, I don't have a degree in chemistry or anything like that. I looked up radioactive half-lives on Google, and I found a listing, and I found that cesium-137 has a half-life of 30 years. Okay, so that means that when there's 100% of it, remember how we did this? Oops, I'm sorry. Remember our table looked like 1/2 to the 0 power, and that's 100%. Okay, and that would be 0 years old, right? Okay, and then when I do 1/2 to the first power, well, there's only 50% left, right? Okay, and then that means the substance would be 30 years old. So the half-life tells me how long it takes for half of the amount existing to decay. All right, so then when I do 1/2 to the second power, that would be 25%, and we would be 60 years old, right? And then 1/2 to the third power would be 12.5%. Okay, and that would be, oh, I have a mental blank here. Hold on. Sorry there, folks. I just had a moment of insecurity, and I wanted to go check my facts before I continued on with the video and made a mistake that one of you would correct me on Monday. But, you know, I really appreciate you guys doing that. Seriously, I know I tease you about it, but it's good. I really love the fact that you guys have enough courage to challenge me, because I am not perfect and I don't know everything, and I'm going to make mistakes from time to time. So challenge me, and we will discuss it, and we're both we're all going to learn more that way. All right, so this would be 6.25%, right? And let me see here. I'm losing my place. This would be 90 years old. This would be 120 years old, right? And then I probably should go down one more. That'd be what, 3.125%, and we'd be at 150 years old. Okay, now I'm only going to use, I'm going to get rid of the 1/2 because they're in my way for the calculations I'm doing. So what I'm going to do is I'm going to kind of set up a timeline here. And I'm going to make this really neat. I'm going to pause the video, and when you unpause it, you're going to see my timeline up here. Okay, so here's my timeline. It got a little crowded down when we get down to about 3%, 3.3 and 125,000%. The 0 is only on there to help me find the halfway marks. Really, there would be no 0 on this because the substance can never totally disappear. If I continually cut it in half, cut it in half, cut it in half, cut it in half, eventually I'll get such a small amount that it's like having nothing, but I will never actually get to 0. Okay, now, there may be some other things that will help me out. Like, for example, 75% would be in between 100 and 50. I may even want to find the halfway point between 75 and 50. Okay, well, let's see, that would be, add them together would be 125, right? And half of 125 is 60. Oh man, my math is so slow today. Pardon me for 1 second. Yeah, silly, I'm having trouble with the simplest math. 62.5. Okay, I can come in here, and this will help me get a better ballpark for my estimate. I can go in between here, halfway. I think it's going to be 87.5, but I'm just taking that from memory. Half of 170 would be 85. Yeah, I think that's right. Okay, and then halfway between 50 and 25, I think would be 37.5, right? Half of 75, right? 74 would be 37. Yeah, there we go. And I'm not going to come over here and cut these in half anymore because it's going to get really crowded. If I need to, I will. But let's say the problem was asking me, oh, I should put the years up, shouldn't I? Okay, well, if 0 to 50%, or 100% to 50% is 30 years, then the halfway point must be 15 years, right? Now, what's the halfway point between 0 and 15 years? Well, half of 15 is 7.5 years. Okay. The midway point between 15 and 30, well, 45 cut in half would be 22.5 years. And see, narrowing it down this way, I can give a better estimate. Halfway here, I think, would be 45 years. Okay. And like I said, I'm not going to cut those down anymore. So if a problem asked me to find the amount or the age, the approximate age of some cesium-137 when there was 90% of it remaining. Well, I know 90% is going to fit right here. That's going to be a little bit younger than 7 years. I might say, well, 7 years. Or I could say, like, 6 years and 12 or 11 months, something like that. Okay, if they asked me for one more in the middle, like say they wanted 43%, well, I know the distance here is 7, and the distance here is 6. I'm going to need a number in the middle of the two. Well, I'm going to take 50 plus 37.5, and then I'm going to add, okay, and then I'll take half of that. So 87.5, and I know my answer is going to be pretty darn close to 44. Okay, 7, 3, 6. Make sure I subtract right. 15. What am I going to get there? 7 would be 14. 75. So, yeah. Oh, silly me. Yeah, okay. I should have been taking the average of 30 and 45. Okay. I don't know why I averaged those two, but I did, but it's cool. So, you know, this is smack in the middle here of 50 and 37. So my answer in the years is going to be pretty darn close to the middle of 30 and 45. Well, the middle of 30 and 45, let's see, that's a difference of 15 years, 7.5. The middle would be 37.5 years. Okay, so if they're asking for the amount of cesium 137 left at when you have 43%, if they're asking how old it is, my answer is going to be just a touch older than 37.5 years because 43% is just 1% closer to 45 than to 37.5 than it is to 50. Okay, I'm not speaking very well, but I hope you understand what I'm trying to say. So my estimate here would be, you know, maybe just under 38 years. Okay, so that's what I'm doing. I'm just spreading it out and averaging, finding medians and things like that. I don't know about you guys, but I find this stuff very interesting, even though I don't have a science background. It's pretty cool stuff. All right, so go ahead and get that faux quiz done for the weekend. Obviously, we'll be having a real quiz coming up soon, and we will be starting the one last thing before we finish this chapter. All right, Mr. Lawrence signing off. Good night, everybody.